So in the previous video, we have seen how to measure the performance of an algorithm and different complexities of an algorithm. So in this video, we will see in detail about big O notation. Consider this example of calculating sum of first n natural numbers. So this is the simplest way in which we can calculate the sum of first n natural numbers. So what we'll do is you will run a for loop from 1 to the given number n, and you will keep adding this index to the sum. So as you can see, the number of times the first line of code is executed is 1, and next we run sum equal to sum plus I in a loop. So that is run n times. That is nothing but the input number, and the last statement is executed once. So if you calculate, the total number of lines executed is n plus 2. So let us extrapolate this to higher numbers. Let us say input size is 10, then the number of lines executed is 10 plus 2. For 100, it is 100 plus 2. For a fairly large number, it is that number plus 2. As you can see, as the number becomes bigger, this plus 2 becomes insignificant. So what we can consider is complexity for this is big O of n. So while considering complexity, the highest power is considered. So here highest power of n is 1, and plus 2 is ignored as it doesn't have any n factor in it. So let us say if you have a complexity like n square plus 2n plus 3, then you can ignore the remaining part and consider the complexity as big O of n square. You might have seen in your math classes that there is another way to calculate the sum of first n natural numbers. So we can use this formula n into n plus 1 divided by 2 to calculate the sum of first n numbers. So the code will look like this. As you can see, there is only one line of code, and yes, there are multiple operations happening here. First we add 1 to n, then we multiply that with n, and then we divide it by 2. If you split it and write, it will be 3 lines of code. Since the number of lines executed does not increase with the input size, here we have a constant time complexity. It doesn't matter how many number of lines you have, as long as the number of lines does not increase with the input size, we can consider it as constant time complexity. There are other different types of complexities other than the constant time complexity. The big O of n is called the linear time complexity. That is, as the number n increases, the complexity increases linearly. So let us say your program has two loops, nested loops, one loop inside another. Both are running n number of times. In that case, we have a quadratic time complexity. We will see programs which has quadratic time complexity in the upcoming videos. The next one is logarithmic time complexity, which means after every iteration, input size decreases by half. In that case, it is considered as big O of log n. The next one is exponential time complexity, where the complexity is 2 raised to n. We will see an example for this in the upcoming videos. So we have this cheat sheet where we can refer which complexity is good and which is bad. So if you have big of 1 or big of log n, then it is considered really good. Big of n is also okay, as it becomes big of n log n or big of n square, it is considered as bad. So you should see how you can optimize your algorithm so that the complexity is near this green or yellow zone. So that's it about big O notation. So in the next video, we will see big O complexity for arrays and objects. So if you like this video, please do consider subscribing to the channel. It motivates me to publish more content like this. Thank you for watching. See you in the next one.